All right. Hello, friends. We are going to venture into chapter 7. Actually, I'm starting this and wondering where my glasses are. Okay, there. All right. We have studied a bunch of different types of equations. We studied linear and quadratic and all these different things. And every equation has a different graph style. So like when we did y equals x, those were all lines. When we did x squared, those were all parabolas. We just finished doing what if x is on the bottom, and those had the two different branches. So now we're going to study something called exponential functions. And exponential functions have x in the power or in the exponent. That's why they're called exponential. Exponent. Yeah, I forgot an entire syllable. All right, then. So the general equation is this thing. A is going to be kind of like your start value because it's what you have when x is 0. And if that was a 0, b to the 0 would be 1, multiplied by a would be a. So you get a point when you plug in 0, you get out that a value. B is the growth factor or the decay factor, and we'll determine that in a minute, but it's the base, meaning the thing raised to the power. All right, so growth. Exponential growth means it grows and grows and grows at a faster and faster rate, like bacteria or a rumor. You tell two people, they each tell two people, they each tell two people, and it gets out of hand fast. So growth will happen when your A is greater than 0 and your B is greater than 1. So the number raised to the power is bigger than 1. So the base is then called a growth factor because it's growing. And the graph will start off really small and zoom up faster and faster and faster. That, my friends, is the general shape of the graph, just like the general shapes I was showing you up here. So from now on, you're like, oh, that's exponential growth. X must be in the power. If it's going up like that, B must be greater than 1. Lucky for you, the domain of these is always all reals, so that's going to be an easy answer. The range is how low can it go? Well, you can see you have a horizontal asymptote, which is like this little floor down here, and that's currently located at 0. So your range is going to be everything above that. So these two will always have the same number. So the graph is always over that. And then this point is that 0A I talked about. The specific shape of it, like how fast it goes up and down, you'll figure out as you plug in numbers to your calculator in each specific question. Well, what if it's not growing? What if it's decaying? So think about things that go down in number, like the basketball tournament. You have 64 teams, then you have 32, then 16, then 8, then 4, then 2. You're cutting it in half each time. So that's going to happen when your A is greater than 0, but your B is less than 1. So then the base is called a decay factor, or like depreciation. So it's getting less and less over time. Like I said, always is always, and the domain is always that for these. You still have that horizontal asymptote, like the floor that the graph never touches, but now you're starting high and zooming low. You come really close to but never touch it. So it's the same shape, just flipped around, and it's still going to cross here at your 0A value. So your range is actually still the same. It's staying above 0 because that's the location of the horizontal asymptote. And these two will always be related to each other. So that's the general gist of it. And then like it'll just depend on the specific numbers. So in this problem, I am going to draw in my horizontal asymptote. I'm going to go ahead and write it down. I'm going to say my graph's going to be above that. And I know that my domain is always all reals. So I'm going to try like -2, -1, 0, 1, 2. Now, what you're going to end up doing, if you want to do this on your calculators, you're going to have to go 2 raised to the -2 power on your calculator, and it's actually going to give you 0.25. You'll do 2 raised to the -1, 2 raised to the 0, anything to the 0 power is 1, 2 to the first, and 2 to the second. So if I plot those at -2, I'm only at like 0.25. At -1, I'm only at 0.5. 0's up to 1, 1's up to 2, 2's up to 4, and then 3 would actually be all the way up to 8. So you can see that it just starts going faster and faster and faster and faster. It grows exponentially. So both ends continue forever. This kind of goes gradually out but up, and this one goes closer and closer to that asymptote but never touches it, never crosses it, and that is my exponential growth. Here, this one is going to be decay because my B value is a half, and that's less than 1. So this is going to decay. It also has a 4 out in front. So you'll notice that over here, when I plugged in a 0, I got a 1. That's because technically the A value out in front is just a 1. Here, when I put in that 0, I expect to get a 4, but we'll check. And then, I don't know, maybe you want to try a couple before and a couple after. Here, when you do this, make sure you're typing in 4 times 1/2 and then raised to the whatever power you're doing. So here you should get, and check it on your calculator that you're getting this correct. Actually, that's 16, sorry. So this one should come out to be 16. This should come out to be 8 on your calculator. This should come out to be 4 if you do 4 times 1/2 to the 0. Then this should be a 2, and then this will be a 1, and so on. But I'm going to have that horizontal asymptote here at 0. My range stays above that. My domain is always all rails. And if I go to negative 216, it's like way the heck off my graph. Even negative 1,8 is off the graph. And then it drops to 4 at 0, 2 at 1, and 1 at 2. So you can see that it comes down really fast and then is going to like plateau out and stay above that line. Because in this case, with the 1/2, you're taking half of a half of a half of a half. So this would go to 0.5, then 0.25, then, and so on and so on. So it gets really, really small, but it never actually gets to 0. All right, then we have done this with every single kind of graph we've ever graphed. What happens as you do some transformations? In every single graph we've done, this number at the end that's added or subtracted, like here's our core problem right here. This is added after, a positive moves it up and a negative moves it down. And in this case, that's significant because yeah, a positive is gonna move it up D units, a negative is gonna move it down D units. That is gonna take the horizontal asymptote with it. So now it's going to be located at that D value. And that's going to impact the range because the range and the horizontal asymptote are going to be based on the same number. In our past experience, the things that are happening inside with the X, those are actually left, right, and they always do the opposite of what you expect. So a positive C actually moves it to the left, and a minus C actually moves it to the right, which is the same as we saw with parabolas, absolute value graphs, every single thing we've done. So in this problem, before I start, I can look and go, oh, this one's going to move to the right, 1. It's going to go down 3. Because the 2 is greater than 1, this is going to be growth. Okay, I definitely know my domain, and horizontal asymptote is equal to the D value now that we have one. When we didn't have one, it was 0 because there wasn't a D value. But now I moved the whole graph down 3. So my new floor or horizontal asymptote for this graph is located at y equals negative 3. Which also means my range is now greater than negative 3 because the graph is going to go all the way down to that floor. Now, this is tricky to get into your calculator, and I don't know how many points you really need because you already know the shape of the graph. But say that you put in a couple of numbers. And then when you type this in, make sure you're telling your calculator that that whole thing is in the power. Hang on, I'm getting my calculator out. So each one you're going to be doing 4 and then times 2 and then raised to the power of, and then whatever your x is minus 1, then you put the parentheses closed so that it knows you're done with the power, and then you have your subtract 3. Okay, so I'm just kind of plugging some numbers in. Here I'm getting negative 2.5. Here I'm getting negative 2, negative 1, 1, 5, and so on. I don't think I typed that in right. 4 times 2 to the x minus 1 minus 3. Start at negative. Okay. So if I go to negative 2, I'm down 1, 2.5. At negative 1, I'm down 2. At 0, I'm down 1. At 1, I'm up 1. At 2, I'm up 5. And so the points are aligning where it's going to do exactly what you would expect. It's going to grow exponentially from left to right, but get really close to and never touch that floor. Here, looking into this next one, I kind of think about what should I expect. This is going to move it to the left 1, which is just kind of hard to see. This will be easy to see on the graph because this is going up 2. So that is going to move the whole thing up to, including that floor, that horizontal asymptote's now at 2. So my range is now going to stay above 2. My domain is always the same. So if I'm going to put a couple numbers in to kind of see where I'm at, I'm going to have my 3, and then I'm going to have my 1/2, and that's going to be raised to a power. And again, put the power in parentheses if you need to, so your calculator knows that you are putting, like, that whole thing is in the power. Sorry, I'm still trying to put it into my calculator. And I have my +2 at the end. Sorry about that. Okay, so now when I'm looking at, like, plugging in my numbers, I have, when I put in a -2, and you should make sure that you know how to get these numbers. Don't just copy mine, because you want to know how to use your calculator and get these numbers to come out. So when I put in a 1, I got 275. When I put in a 2, I got 2.375. Those numbers seem weird, but if you go in here, you're going to be at -2 up 8, -1 up 5, 0 up 3.5, 1 up 2.75, and then 2.35. So it actually looks exactly like you would expect. It's coming down from left to right really fast at first, and then less and less and plateaus. And the reason this one is coming down from left to right is that it's decay, because my b is 1/2, which is less than 1. That, my friends, is 7.1. So the worksheet's just going to have you go through and graph them. Make sure you draw your horizontal asymptote as a part of the graph. Thanks, guys.